Hello, everyone. We've got to the end. This is the valedictory video of what have we done and where have we come from and what have we covered in the course. So we did module 1, which was introduction and key concepts. What did we talk about, Michelle?
Well, Peter, you started off with really highlighting the last 20 years of research, I believe, maybe longer, that you and your group have been involved in around rainwater harvesting and some of the really profound and interesting insights that evolved from that research. This idea of a rainwater treatment train, that rainwater storages act as bioreactors, the importance of the biofilms in the sledges, right? I think this can't be understated, especially given the literature out there that actually encourages people to desludge and sterilize and clean their tank. So I think that one is absolutely key. There was an introduction around this discoveries around domestic hot water systems and how they're also like this incidental treatment. It happens as part of the entire treatment train. And what is the microflora, the is it the right biology that's just naturally present in natural waters like rainwater.
And wasn't that fun? And we had some learning objectives. And we learned about the
Mm-hmm.
real and substantial benefits of to water supply networks and stormwater management when rainwater harvesting is considered, using
Mm-hmm.
systems thinking and
Mm-hmm.
systems framework approaches. And we also learnt that
Mm-hmm.
decentralized and distributed solutions like rainwater harvesting improves the economic efficiency of the entire system and provide
Yeah.
huge societal benefits.
Yeah, so the idea there being that, even though your rainwater harvesting system is a really local solution, we presented some of Peter's research that looks at the influence of these decentralized local solutions on the system as a whole. These another way cumulative impacts on the system.
So it's consistent with the ecological sustainable development ideas from a decade or two ago, where acting locally to produce global benefits.
Mm-hmm. Our next module is module 2, and we dove right into conversations around water quality.
Yeah, and why design standards for rainwater harvesting and drinking water guidelines don't often apply very well to home scale rainwater systems.
Another one of those systems thinking concepts. Hopefully, that's a theme that you've seen or a pattern you've seen repeat itself over and over in this course, where there's these ideas, there's these concepts that aren't aren't applied correctly necessarily.
And what are the credible health risks and credible risk pathways when it comes to domestic rainwater harvesting systems? So here we
Mm-hmm.
separated out the speculation from the reality.
Mm-hmm. And really, I hope helped support the reality that rainwater is low risk. It's not a high risk water source. Unlike the impression you might get from some codes and standards.
And we also unpacked laboratory testing for rainwater, which can be quite confusing and misleading. What are the microbiological and physical parameters on common lab tests, and what do they mean, and what don't they mean?
Mm-hmm. Mm-hmm.
We
Maybe what don't they mean is the was the bigger was the bigger thing of those two.
and Michelle, we talked about when you
Mm-hmm.
should consider testing your rainwater.
Yep. Not very often. I mean, unless you have definitely not part of a routine monthly basis. If your water is clear and it doesn't have any taste, little taste, and doesn't smell,
It's,
arguably there's no justification to test your water.
and in fact, we gave students common sense processes to ensure their water quality was okay.
Mm-hmm. Mm-hmm. Module 3 was about the anatomy of a rainwater harvesting system, really understanding that there's just like there's anatomy of the human body and there's all these components that work together. It's the same thing with your rainwater harvesting treatment train. So we talked about what all those different components were, and the importance of placement and why placement is a crucial consideration for the designer, and how to use a site plan and an elevation drawing to really start um, your design process.
And we learnt high-level principles related to design, operation, and maintenance that must be considered early in the design phase. So that get it done before
Mm-hmm.
you buy stuff.
Yeah,
Yeah.
because you really have to understand how your system is going to be maintained and operated during your design phase and when you're laying things out, right? It's just absolutely crucial for successful design to be considering that long-term operation.
Yeehaw. Supply, demand, and sizing. And this is such an important module in this course.
Mm-hmm.
Throughout the world, people start here, but this should be after
Mm-hmm.
you've considered those three modules that Michelle and I have just taken you through. This isn't the start of the process. This is the middle of the process.
Mm-hmm.
Uh,
And I think another key learning here is that people often start with the size of the storage, and you know we really want to emphasize that the size of your storage is simply an outcome of how you choose to manage your demand, particularly, and also your supply.
yeah, and we looked at how your particular design scenario, which could be off-grid or supplemental, where it's backed up by utility water or a primary source, will influence the strategy for sizing your rainwater harvesting system. And as
Mm-hmm.
Michelle just said, the size of the storage is probably not the main parameter here. It's your roof area, your demand, so catchment area, your demand, and how you behave around your demand. So
Mm-hmm.
producing a massive storage um, to get 100% reliability, or producing one that's a quarter the size, and realizing that if it's dry, maybe you'll use it less rainwater because you'll be managing your storage, is a very interesting concept to consider.
All right. And so we also introduced you to the essential rainwater harvesting tool, this spreadsheet calculation model, but we really emphasized that using a mathematical model is useful, but it's critically important to be aware of the assumptions that are going into the model, and then the limitations of that mathematical model as well.
And we had a monthly model and a daily model, um, not because all models are right, and more detail makes it more right, but to understand the variations in that happens day to day versus monthly in a rainwater harvesting system. But the key message here, all models are wrong, but some are useful, and these models are useful to help you fully understand your design.
Yeah, and I think students should really have seen now how the daily model is most certainly more insightful than the monthly model, but it's also quite a bit more cumbersome, and the data is harder to get. So there's this trade-off between the options, the monthly versus a large multi-year
But
daily data set.
but we've told you how to do both, and Michelle's giving a
Mm-hmm.
great video of how to go and get that data. And if you get
Mm-hmm.
stuck, I'm sure you've got Michelle's email address. We did collection and pre-filtration.
Yep. So took it back to the essentials or the ideas around your roof and choice of materials. Although I think one of the big outcomes is that your material selection has far less of an influence on water quality than you might have previously thought. At least that was a huge insight for me prior to diving into a lot of this research.
And the sizing of gutters and uh, piping is only a peripheral consideration to the rainwater system designer. And in most cases, if it's an existing house, these things already exist. So you just have to know
Mm-hmm.
how they work and what the limitations are. You really don't have much choice on what these elements are.
Mm-hmm.
And pros and cons of pre-filtration option, including gutter screens, downspout
Mm-hmm.
filters, first flush diverters,
Mm-hmm.
and centrifugal filters. Whirligigs, we did
Mm-hmm.
those too.
Yeah, we did those too, but we really, really talked about why Peter's favorite pre-filtration devices, hands down, one of those simple downspout filters, and how surprisingly effective such a simple low-cost device is in improving water quality.
We also talked about where filters exist throughout the rainwater harvesting system that we're not aware of. For instance,
Mm.
at the pump, inlets and outlets to the rainwater storage should have a mesh screen, and all of these things add up to a treatment train of devices that are just part of the system that we hadn't been counting before.
Mm-hmm. And then the last thing in that module was wet versus dry conveyance and the different design considerations depending on how you want to convey water from your roof to your tank and whether you're going, below ground or going down and back up again and have standing water in your pipes.
So the golden rule is keep leaves and debris out of your wet system and out of
Mm-hmm.
your dry system too, and you won't have smelly water.
Mm-hmm. The last module, or at least content-based module, was module 6 around storage, pumps, and end use. And this module was about everything from your tank onwards through to where you use the water.
And we talked about the difference between mains water bypass and top-up systems when it comes to providing backup water from utility suppliers or other suppliers for your rainwater harvesting system.
Mm-hmm. We talked at length about pumps and how to think about your pump sizing and your fixture flow rate. We even dove into some Bernoulli equation stuff and some pump curves. Yeah.
And we also found that bigger is not better with rainwater harvesting
Mm-hmm.
pumps. So as hard as that Bernoulli equation sounds, or the approximate methods Michelle's taken you through, it's worth knowing about to ensure you size your pump system properly. Particularly if you're
Mm-hmm.
also concerned about energy and you're off grid, you need to have a think about those things. So a bigger pump is a cumulative difference in energy consumption.
Mm. Then we chatted about both hot water supply and final filtration and the roles that those two components play in your treatment train.
And we also talked about cold climate rainwater harvesting and some design ideas to address the cold climate challenges. I wish it was
Mm-hmm.
cold here right now, but we're 20 or so degrees at least hotter than you guys.
Hmm. And the last thing was when you should consider cleaning out your tank. We provided a sample protocol and a step by step kind of checklist to think about if you do have concerns about the quality of your rainwater system.
And that's it. It was a fantastic journey with the webinars
Mm-hmm.
and great questions. It was
Mm-hmm.
transformational, actually, putting, in my case, more than 20 years of intense research and practice knowledge into conversations with Michelle and her
Mm-hmm.
experience around verge permaculture to turn this knowledge into a course. So it was good
Hmm.
for us, and we hope it was good for you. Um,
Yeah.
However, you're not finished. We want you to do
Mm-mm.
a personal design project, don't we, Michelle?
Yeah, we do.
Yeah.
And in the next lesson, I'm going to give you some instructions on exactly what we're recommending you do. And we want you to take all this knowledge and put it to productive use. Don't just let it fizzle out. Take it all and apply it to a real project if possible. And that's going to really enhance your learning.
Maybe your own house or someone else's
Mm-hmm.
house, but
Mm-hmm.
it will close out
Absolutely.
this course really well.
Mm-hmm. All right. Thank you so much.
Thank you also.